Okay. We talked about binary search, and we even showed, well, we showed in one slide that binary search is pretty much the optimal comparison-based searching algorithm, essentially, for now. But what we want to look at now is sorting algorithms, because in order to do your binary search, you're going to need to sort it first. So we need to at least look on how we would sort something. All right. There are many ways to sort. There are a lot of ways to sort. If I gave you a bunch of cards, I'm just curious how y'all would do it. If I gave you a bunch of cards, how would you sort them?
Just put them in a pile and put them together.
Put a pile, and then just
I'd sort them by color first.
sort them by color, okay?
And then do sort those two from the like the spades, hearts, and whatever.
All right, and then when you do, let's say the spades, how would you sort those?
Put that towards like the bottom, and like the numbers, but like, yeah, numbers would be on top. So,
Okay, so you have spades. We'll just say that it's what, ace through king. So how would you sort those?
Ace would be at the bottom, and then go.
Well, I mean, you have a bunch of cards. What would you do? I get that you divide it out in four first. Let's ignore that for now.
Okay.
You have eight. You need to do ace through king, but all your cards are all sort of.
I'd line them up.
You line them up. Okay, so you flip them all over, line them up. They're not sorted.
Okay.
And then what would you do?
I'd put
Pick up
ace
the
at the
ones.
beginning.
Okay, so you pick you select the one that goes in the beginning, put it there, and then you select the one that goes next, put it there. Okay, so that's a selection sort. That's a good one. Any other ways to do it?
See, like stack,
Stack.
the one on the bottom, and two, three, four, five. No, just like a stack.
Yeah. Okay, so that one's still selection sort because you're selecting where they go. All right. So there are other sorting algorithms. Selection sort actually I think is the most intuitive because that's what y'all thought of doing, and that's what as humans we want to do. We're like, all right, you go here, you go here, you go here. There are other sorting algorithms for computers. The first one we're going to look at is something called bubble sort. The advantage of bubble sort is that it's going to be the easiest one to code. That is its only advantage that I know of. Oh, and it works.
That's nice.
It is nice, right? This one is very easy to code. I'm not going to code it because it's part of your lab. It's really simple. If you can't do it, I'm sorry I've been calling it simple. Come talk to me. We'll have to have a discussion. Well, let's suppose we have a list from 0 to n-1. In a series of n-1 iterations, compare successive elements, index and index plus 1, and if index is greater than index plus 1, swap it.
That's it.
That's it.
Oh,
It's not. Let's do what's that?
I'm joking.
Let's do an example. Compare the 10 and the 7. The 10's greater, swap them. Compare the 10 and the 19. 19's greater, don't do anything. Compare the 19 and the 5. 19's greater, swap them. Compare the 19 and the 16. The 19's bigger, swap them. The 19 is where it needs to be. It has bubbled up, or bubbled down in this case, to its proper location.
I think we did this in Java, right?
Quite possibly. Good. Then this lab should be doubly easily.
Double.
I don't know.
I know.
Double.
I'm a Java for that. Yeah, 70.
7 to 10. Compare. Don't do anything because 10 is bigger. 10, 5. 10's bigger, so we're going to bubble that or swap it. 10, 16. 16's bigger, so we leave it. 16 is where it needs to be. It has bubbled up. 7 and 5. 7's bigger, swap them. 7 and 10. The 10's bigger, we're done. The 10 is bubbled to its location. Unsorted of two elements, you compare them. They're in the right location, we're done. Any questions? I'll tell you right now, 2 for loops. Because each time on the outer side, you're going through the whole list. And then for each iteration, you're going through what's left of the list and bubbling everything, doing the comparison and then swapping. All right? Everyone good?
Yes.
What's the big O? What's the total number of comparisons? There's different things to test here. Let's first do comparisons. Well, It's got to compare everything to each other. It's actually going to compare it twice. The first time you do n-1 comparisons, because you got to go through the whole list, compare everything. So it's n-1 comparisons, because you compare two things. Next time you'll compare the last thing, so n-2, n-3, et cetera, all the way down to 1. Ends up being n times n-1/2, 1/2 n squared minus half of n, which is big O of n. So you're doing n squared comparisons. Good or bad? Eh. Yeah. Well, at least it'll complete your lifetime, right? Right. That's good. Number of compare assignments, worst case. So if you had to assign every time you swapped, basically it's going to come out to the same thing of n squared. Oh wow, that was it. And that's going to be it for bubble sort. Wow, we're done. Any questions on bubble sort? Comments? Screams? Oh yeah.
Do you want, like in the lab, do you want us to do this with 2 for loops?
Yes, unless you want to do it recursively. But I don't see a need to do bubble sort recursively. Although you could, that would be a music watch. No. How would I do that? No. You put that idea right back in. You must do bubble sort recursively. No!
Oh, no.
All right. Good. Let's go look at your